Hello guys, hello everybody, welcome to Unacademy, welcome to the course. Now today we are at the end of the syllabus, that is graph theory. Today and tomorrow we will be discussing the graph theory. Right. Okay, let me give my introduction. This is Bhima Sankar. I did my MTech from IIT Kharagpur. I have around 10 years of teaching experience in GATE and ESE throughout the country, in almost all corners of the country. I am expertise with the subjects of digital circuits, network analysis and microprocessors. In the last 10 years, I trained more and more number of thousands of students every single year from all corners of the students, which includes rankers, droppers, whatever we call, even the weak students, those who started from the very basic, every single type of student is there. Okay, my intention to teach is every single student should get benefit from my class, whether he is a basic student, whether he is an advanced student, it doesn't matter. Every student should have something from my class. Whether he don't know anything, he should be able to learn. If he know something also, he should think, okay, we can learn like this also. That is the intention of my class. Now, let's move. Good morning, everybody again. Good morning, Deepak, Vishnu. Okay. So, let's move. If you want to go for Unacademy Plus subscription, क्या हुआ? ऐसा move हो रहा है. Right. If you want to go for Unacademy Plus subscription, you have multiple benefits with the Unacademy Plus subscription. In Unacademy Plus subscription, if you see, we have a live classes every day. Morning and evening we will be having the classes in general, so that the regular college going students will not disturb. Even we have the in between also different batches we are having. Once you join Unacademy, you can attend any single batch or any multiple batches also, no restrictions, according to your convenience. And your learning experience will be definitely multiple times enhanced compared to your YouTube classes, because the learning platform of Unacademy is very interactive. You feel like we are teaching one-to-one, right? So in Unacademy we have multiple batches. You can watch them in live or in the recording also. If you see here, we have crash batch, rank improvement batch, different batches. Every single student from basics, target 2022 for the second year. So for everybody there is a batch. You can join and watch any new initiative, old initiative and the current initiatives of the Unacademy. And also you will be getting free test series of our Kreatryx channel, completely free for you once you go for the subscription. You will be having regular exams like weekly exams, monthly exams, subject wise exam, topic wise exam. Everything is free for you, unlimited practice, and your doubts will be solved more effectively with the help of doubt solving sessions. And also our classes are in both the languages, English and Hindi. So this is about Unacademy Plus subscription. If you go for Iconic, you have extra benefits than your Plus subscription. What are the extra benefits with the Iconic subscription, sir? In the Iconic subscription, you will be getting a personalized coaching with the help of a digital coach. Other than these classes, extra benefits you will be getting is, you will be getting a personalized coach, study planner who will check your performance on the test. Based on that, he will evaluate you and he will give you the proper guidance to reach your goal, guys. So according to your requirement, you can choose either Plus or Iconic. So if you go for Plus subscription, you know, this is the coupon code you should enter. If you like my teaching, if you want to join Unacademy, it will show that you are entering Unacademy by liking our teaching. So it will definitely count for the faculty. It will be like a valuing us. If you use our coupon code, it is showing your like to us. Whenever you join, you can apply this coupon code. You will get 10% extra discount on any course of Unacademy. Not for my classes, I am saying for GATE and ESE or any subscription of Unacademy. You can select Plus. 1 year is very much affordable. It's just 27,000, hardly 2,200 per month. If you go for 18 months, it is this much, 34,650 after 10% discount. Originally it is 38,000 something, and 2 years It is originally 44. After discount, you will get it for 39,600. Second years के लिए this one is the best. For third years, this one is the best. If you are preparing for ESE exam, this one is the best. According to you, you can select whichever suits for you. Right? So you can go for the 3-month subscription also if you are a final year, or if you are writing this year only, already attended some classes or somewhere, you want last 3 months to be utilized properly, because the last 3 months of the preparation is the very important part of your total preparation. So you want to take the extra edge, you can go for the 3-month subscription and watch all our videos without any restriction. If you go for Iconic, these are the prices for 1 year and 2 years. So this is my profile name in Unacademy. You can search this and you can message there, or you can contact me, or you can watch my all free classes, etc. Right? Right. So let's start the class. Yes, Samay, I know I already explained the same to the students. Okay. So let's start graph theory. So you people might heard this word graph theory. So can you tell me why we use this graph theory? Do you have any basic background knowledge about it? ग्राफ थ्योरी का मीनिंग क्या, ग्राफ थ्योरी कहाँ पे यूज करेगा? पहले ग्राफ थ्योरी, व्हाट इज ग्राफ थ्योरी? इज ए मैथमेटिकल कॉन्सेप्ट. ओके, इट्स ए कॉन्सेप्ट फ्रॉम, वी ऑलवेज borrow from the maths only. So it's a mathematical concept we use in number of applications. In civil engineering, in the transportation, to find the nearest paths, etc., they will use it. In computer science, they will use it. Different areas, every area we will use this graph theory. So हमारा electrical networks में how to use the graph theory? What is the need of this graph theory? Please tell me. Tell me. What's the need for this graph theory? Yes, yes, yes. You can see graph theory is a mathematical concept. It is used in our networks. Suppose you want to have, you have a big network, complex networks with more number of nodes, meshes, etc. If you want to solve it using computer, so in computer you should represent the network in a way your computer is able to understand. That is, with the help of matrices, we represent the network by some different basic matrices. Those we will discuss it further. Okay. So by using the matrix multiplication, etc., you will be able to find the node voltages, etc. That is by, if you want to solve the network with the help of your computer, you should take the help of graph theory, which will make your analysis easy. That is, more complex networks where you have more number of nodes, meshes, where you cannot solve manually, we take the help of this graph theory. Okay, right. Chalo, that is the need, why we need the network, what we call graph theory, right? So let's see what is the meaning of the graph theory. In the particular course we are discussing now, in the objective point of view, whatever required for you, that part I will discuss. That is how to convert network into a graph. After converting into graph, what are the matrices we are having? What are the basics of terminology of the graph theory, like what we call trees, code trees, matrices, etc. Everything we will discuss in the particular graph theory session of YouTube. It's extra part you require for convention of ESE. Conventional ESE may sometimes they give network, they ask you to find the node voltages using graph theory concept. That we may take it in the marathon session or somewhere when I take for the conventional part of ESE. So let's continue here. So let me take some random network like this. Just randomly taken, guys. let's give this as a numbers 1, 2, 3, 4, 5, 6 branches. Okay. Now you see this is the network. I want to convert this network into its corresponding graph. So please listen here. You can draw, there is no need of ice cream shape. Okay. You can draw like this also, it doesn't matter. Okay. This is the most frequently taken example, most of the cases for the convenience. So this is how you convert network into graph. Sir, इसका meaning क्या है सर? अगर every element को short circuit किया तो we are losing the identity of the elements क्या? नहीं, we will use them. Okay, first we can. This is the first step we are doing. Then, so this is the node 1, 2, 3, 4. Right. So these are the nodes, right? So now listen here. Good morning, Rajesh, Rupesh. See here, you people should attend the class for the sake of knowledge, not for the sake of exam. Okay, you see yesterday more strength is there because from that question comes compulsory. Here this is not in the GATE syllabus, so people don't come because they do, if you generally whoever comes, for those students I am saying what you are doing is perfect. That is, you attend the class for the sake of knowledge, automatically your rank follows you. Okay, so let's see here, this is what we call graph of the network. इसका नाम क्या सर? Linear oriented. Oriented का मतलब direction is there. Graph. In this case, these nodes, whatever we are having, what is the name of those nodes is given by vertices. The junction points are called as nodes or vertices, and the nodes are connected with the help of these lines. These are called as edges or branches. Edges or branches. So let's see. Right. So how to make the graph? While constructing the graph of the network, replace all branches with a short circuit. Replace all branches with a short circuit. After that, what to do, sir? What is the, suppose in this particular example, not every time, in this particular example, how many junction points are there? 4. Those are called nodes or vertices. How many branches are there? 6. Right? So before going to the graph theory, we should know the basic terminology or language of the graph theory. Let's go. Good morning, Krishna. So the first thing we discuss is called rank of the graph. Why do you calculate the rank? That you will be knowing in your maths, you will be studying already. Okay, number of independent equations, etc. So rank of the graph is generally, for the particular graph, rank of the graph is given by n minus 1. Suppose if graph is divided into parts, then what is the rank, sir? If graph is divided into parts, then the rank is equal to, overall rank equal to sum of individual rank. Okay, so if one graph is made into 2 parts, you should find rank of it, add it, that will give you total rank of the system. We will use everything, whatever we discuss here. So that's why starting I am giving the basics. So these are the basic definitions we are having. Regular graph, connected graph, complete graph. Okay, so what is a complete graph? Don't read the definition. Let me explain first, then you can read the definition. What is the meaning of complete graph? In a complete graph, between any 2 nodes, there exists only one branch. For every 2 nodes we take, there must be one branch compulsory. That is called as a complete graph. So you can go back. Is it a complete graph? Every 2 nodes ko ek branch hai. It should be only one, not more than one, not less than one. This kind of graphs are called as complete graphs. If you have a complete graph, how many branches are possible? Okay, the number of branches in a graph with, I'm sorry, in a graph with n nodes. if you have a graph with n nodes, how many branches are possible in a complete graph? Not every time. Okay, in a complete graph. How many are possible? Tell me. You should just analyze. If you have a complete graph, how many branches are possible? So you can see between any two nodes, there exists only one branch. So how many combinations are possible? This, if you have n nodes, how many 2, 2, 2, 2 like that? How many two different nodes you can select? Thank you, Sanket. Okay. So tell me guys, if you have n nodes, how many what we call different two nodes you can select? Out of the n nodes, how many two nodes we can select? Please tell me. Out of the n nodes, how many two different nodes you can select? Please comment. अरे टू कैसा हुआ? देखो मेरा पास n nodes है. Out of the n, I need to select two. How many two you should select from the n? How many two you should select from n? Please tell me. Yes, yes. Out of the n, you should select two. How many combinations are possible? NC2. That is n into n minus 1 by 2. N into n minus 1 by 2. Right? Out of the n, you should select two. Different. How many different twos you can select? That is, see here. These two, these two, these two, these two, these two, these two. Like that, out of the n, how many twos you can select is NC2. How many twos you can select is NC2. That is n into n minus 1 by 2. That is 4 into 4 minus 1 kitna here? 6. 4 minus 1, 3. 12 by 2 is 6. Okay. So that is the number of branches. Not every graph, it is in a complete graph. Next, what is a regular graph? In a regular graph, what is that? Every node contains equal number of branches. So now I need to explain with example. Right? So let's start. Suppose this is a graph. This is a graph with 4 nodes. Okay. You tell me, is it a regular graph or complete graph? Please tell me. Comment. Comment on complete graph and regular graph. Comment on a complete and regular graph. Is it a complete graph or a regular graph? Or both? Comment. Yes, very good. It is regular but not complete. Regular but not complete. What does it mean? Complete may between any two nodes there exists one branch compulsory. Here between these two there is no branch. Between these two there is no branch. But it is regular. Every node contains equal number of branches. So right. So now listen. Don't think they are touched. It is not a node. In this case, what about this one? Yes, comment please. What about this one? What about this one? Is it regular or complete? Comment. Is it regular or complete? Is it regular or complete? This one is both, yes, regular and also complete. It is both regular and complete. Okay. Between any two nodes there exists one branch compulsory. Every node contains equal number of branches also. It is a regular node, regular graph and also complete. You can say any complete graph is regular, but every regular need not be complete. Okay. So let's move to the next. Connected graph. Connection hona chahiye. What is the meaning of connected graph? In a connected graph, every node is connected to at least one branch. हर node को कम से कम एक branch होना चाहिए. Okay, so let's see what is the meaning of connected. Every node contains at least one branch. Let me take this example. Okay, here every node is connected by at least one branch. This is an example of connected graph. हर नोड को कम से कम एक ब्रांच होना चाहिए. It can be less also. Now, suppose this is there. Here, this is a node, this is a node, this is a node. This node is not connected to anything. These kind of nodes are called as isolated nodes. These kind of nodes are called as isolated nodes. And this is what we call disconnected graph. In fact, graph theory is not a single chapter to be taught in 2 classes. It's a complete subject. Okay, it's a complete subject, guys. When I study my MTech, I studied as a subject also. Complete subject is there, graph theory. In fact, there is a research or what you can do your PhD on also in graph theory. That much use. Okay, what we are discussing is a very basic part with respect to our network analysis. Right. So that is about your so what is the meaning of connected graph? It contains at least, every node contains at least one branch. That is, no node is left isolated. That is, no node is left isolated. That is the basic of connected and disconnected graphs and complete and regular graphs. Okay, let's move to the next. The next definition I want to give you is a tree. This is very important. Tree का मतलब क्या sir? Paid. Okay. Tree is a very important concept in data structures. Anywhere, whenever you settle down in artificial intelligence, everywhere, these concepts are very important. So what is a tree? Tree is a connected subgraph. Tree is a, now you understand what is the meaning of connected. Subgraph. Subgraph means it is a part of a graph. What is the meaning of subgraph? I will give you. What is the meaning of subgraph? Because you should know every single line we discuss. Subgraph is a graph with less number of branches than original graph. In brackets, at least one. It should have at least one branch less than original graph, then it is called as a subgraph, like set and subset. It is a part of a graph. So now come to tree. Tree is a connected subgraph. Tree is a connected one, subgraph of it from particular graph, which connects all the branches without any closed path. Which connects all the branches without any closed path. Tree branches are called, what is the name of tree branches, sir? Twigs. Okay, tree branches का नाम क्या sir? Twigs. If in a graph with n nodes, if you have n number of nodes, if you connect all the nodes without closed path, if you want to connect all the nodes without any closed path, you need how many branches? Is n minus 1. N minus 1. Suppose you see here, you have 4 nodes of our example we have taken. So this will make a tree. You connect 4 nodes, you require 3 branches. If you add here one more, what happens, sir? It will form a loop. Closed path will be formed. That is the meaning of closed path. If you add one line here, it's not a tree. It having closed path. Right. Next. In a complete graph, if not every graph, every graph is not a complete graph. I told you already. If it is a complete graph, there is how many possible trees you can draw is n power n minus 1, n minus 2. So let me draw it for your understanding. Suppose, let's take the same example which we have taken just now. Let's take this example which we discussed just now. Okay. So now listen here. For this particular graph, what are the possible trees you can have? You can have a tree like this. Yes or no? So it connects all the nodes without any closed path. It will connect all the nodes without any closed path. It is a tree of 2, 4, 5. Is this only one tree possible? No, so many trees are possible. This is one example only. If you want, you can draw like this. This is also a tree. Okay, so this is 2, 3, 4. Tree of 2, 3, 4. Right? And similarly, you can draw like this. Different trees are possible. Everything, whichever forms without any closed path is a tree. So as per examiner, like this, how many you can make is n power n minus 2. You can try at home. N power n minus 2. N is 4 here. 4 power 4 minus 2 is 16 trees you can draw. Right. There is a tree. Similarly, आपको co-tree भी है. What is a co-tree, sir? Co-tree is a graph. Co-tree is a graph formed by. Co-tree is a graph formed by removing all the branches. Removing all the branches required to make a tree. Suppose you are having one graph. In that graph, if you remove all tree branches, the leftover part is called as co-tree. So see here. If you have this graph, for this, these are the trees. Some examples. If you remove this part outside from this whole graph, whatever you get is called as co-tree. Let me draw that. What is the corresponding co-tree means? Other branches. 1, 3, 6. One, 3, 6. This is 6. Just a minute. Okay. So this is 1, 3 and 6. This is called as a co-tree. Similarly, for this particular tree, what is the co-tree is remove these branches from that graph, whatever you get, that is called as a co-tree. Let's go back. So coterie branches का नाम क्या sir? Coterie branches are technically called as chords or links. How many coterie branches are possible, or how many number of links are possible in a given graph is total branches minus tree branches, b minus n minus 1, that will give you b minus n plus 1. Okay, so this is important. So since every tree is having its corresponding coterie, number of trees are always equal to number of coteries for a given graph. Here one more observation, tree should not have loop, but coterie में ऐसा restriction नहीं, coterie can form a loop also, so coterie is not having any restriction, coterie can form a loop, not forming loop doesn't matter, because coterie how it is formed, remove tree branches from the total graph. Okay, so let's move. So using this basic knowledge, we have discussed what is the rank of the graph, complete graph, regular graph, connected graph, subgraph, tree, coterie. These basics we have used. Now use these basics, and now we will move to the matrix of your graph theory, which we require for our network analysis. Generally, what are the matrix we require for the network analysis? We discuss in this our course is basic incidence matrix or complete incidence matrix. Okay, complete incidence matrix or augmented incidence matrix. This is the first one we are going to discuss. It is also called basic incidence matrix. It is represented by A suffix A. It is represented by A suffix A. Yes, cause all nodes must be present in your tree. In your tree, all nodes must be present. Chalo. Okay. 1 minute. क्या हुआ? Right. This is the graph I am taking. So let's represent this with A suffix A. How to get the incidence matrix is a very simple thing. How to get the incidence matrix, sir? How to get the incidence matrix is very simple. Just make like KCL equations. Make KCL equations. Right? At each and every node. So let's make it at node 1. At the first node, what is the KCL equation? I1 is leaving, I4 is entering, I6 is leaving. This will give you 0. This is one equation. Second equation. What is the second equation, sir? I2 is entering and I4 is leaving, I5 is also leaving. Third equation, I3 minus I5 minus I6 equal to 0. What is the fourth one, sir? Fourth one is minus I1 plus I2 minus I3 equal to 0. Right. Krishna, just to show the difference, okay? You can show with dotted or thick line, doesn't matter. I showed just with two different colors and dots so that it will give you the feeling of tree and coterie. It is your own way, no problem at all. So these are the four equations we can make, right? I1 minus I4 plus I6 minus I2 plus I4 plus I5, I3 minus I5 minus I6 minus I1 plus I2 minus I3. Fine. Now listen. This part is done. Now represent it in the form of matrix. Okay, in the form of matrix here. So I1, I2, I3, I5 and I6. 0, 0, 0, 0. These are the equations, right? What about I1 here? 1, no I2, no I3, I4 is 1, I5, I6. Just represent the equation in the form of matrix. I2 is 1, I4 is 1, I5 is 1, I6 is 0. Next, I3 is 1, I5 is 1 and I6 is also 1. Opposite polarities, na? So, minus I1 plus I2 plus I3. Yes, sir, this will make my complete incidence matrix. Complete incidence matrix. Okay. What are the number of rows here, sir? 4 rows. Why 4 rows? Because you are having 4 nodes. You got 4 rows. So, what is the order of this matrix? Rows is n. Columns are 6. Why? Because number of branches are 6. It is n by b. N by b is the order of this matrix. Just a minute. I hope you understand. Now, some important observations about this incidence matrix. What is the use of it? I will show you, don't worry. What is the use of this complete incidence matrix? इसको क्या कहते हैं? A suffix complete or augmented incidence matrix or basic incidence matrix, all are same. Okay, it is most frequently occurred in your IES exam. In conventional, most of the times examiner is giving matrix, he is asking you to construct the tree, construct the graph from the matrix. Okay, so let's move. This is about your complete incidence matrix or augmented incidence matrix. So, right. So, these are the number of rows and columns. Fine, sir. Let's move further. Augmented incidence matrix में one important observation क्या sir इसमें? Can you give me one important observation here? If you add these all rows, you get a row of 0 because 1 minus 1 minus 1 plus 1, 1 minus 1 minus 1 plus 1, they will add on to give you 0. Why? Because current leaving at one node compulsory should enter at another node. If you take positive at one, other should be negative and vice versa. So, here one important point we observe is sum of all rows equal to 0. This is important point. I will use it next. So, here there is no need of representing 4 rows. Why to waste your data? You need not represent the 4th row because the 4th row can be obtained by negative sum of the first 3 rows. Yes or no? 4th row can be obtained by negative sum of the remaining 3 rows. Right. So, let me write that. So, you can eliminate one row as the negative sum of remaining 3. Okay. So, please listen here. You can eliminate one row as a negative sum of remaining 3. Okay. This is what we call incidence matrix. Okay. So, if you remove one row from the complete incidence matrix, the matrix you get is called as reduced incidence matrix. If you remove one row from the complete incidence matrix, what you will be getting is called reduced incidence matrix, which we represent with the A. So, let's move. Because you can eliminate one, there is no need, or you can also say the number of equations required to solve this is n minus 1. This is not required. Okay. So, properties of incidence matrix, complete incidence matrix. First point, for a given graph, okay, your matrix A is unique. For a given graph, the incidence matrix is always unique. This is the first point. And the second point is rank of the graph. Please tell me this. Rank of the incidence matrix is equal to, what is the answer? Can you tell me? Can you tell me from our discussion? Nice. सारे rows add करो. You will get a पूरा row of 0, Kumar. Right. Here you can remove one branch, one row, eliminate one row possible, na? It is n minus 1. It is the same as rank of your graph. Right. This is your rank of the graph or rank of the incidence matrix. Now, listen here. The next one we want to discuss is reduced incidence matrix. See here, since if we eliminate one row from the complete incidence matrix, okay, since what is the rule I told? R4 equal to, it's a redundant information. You can get this from the R1, R2, R3. You need not store R4. That is the meaning. Okay. From A, then it is called reduced incidence matrix. How you represent reduced incidence matrix, sir? We represent with A. Reduced incidence matrix we represent with A. What is the use of it? Everything we will discuss. Just wait. Okay. So let me copy this. क्या हुआ? See here. This is the this is the complete instance matrix, right? Just a minute. Okay. So this is the complete instance matrix you have. In that, if you eliminate one row, remove this part, remove this last wala row, throw it away, then what you get is called, what is that? 1 0 0 0 minus 1 0 0 0 1 minus 1 1 0 0 1 minus 1 1 0 minus 1. Then this is what we call your reduced incidence matrix. What is the order here? N minus 1 into B. That is what we call reduced incidence matrix. What is the use of reduced incidence matrix, sir? What are the properties of reduced incidence matrix? Is the first one. For a given graph, if it is not a complete graph, for any graph you can use this formula. Number of trees possible in any graph is given by determinant of A into A transpose. This will tell you the number of trees required. Trees you can get for a given graph. Next case. Here, if you take A transpose into E is equal to V. Okay, this will relate, this matrix will relate the node voltages and branch voltages. This will help us to relate the node voltages and branch voltages. If you take its transpose, you get n minus 1 here. So this will give you node voltages. You can say node to ground. Ground ka another name kya? Reference. Or you can also call it as datum. You can also call it as datum. Datum is nothing but reference node voltages. And this one is branch voltages. So the what we call this one reduced instance matrix can be used to relate the branch voltages and node voltages of a given network. So fine, let's move further. I already cleared that, Mohan, not sum of columns. Okay, go back. You add these first 3 rows, what you get? 0, 0, 0, 0, 0. Okay, if you add these 3 rows, that is what I am saying. Sum of total rows, not individual elements. Total rows will give you a 0 row. Okay, right. That is about your incidence matrix. Okay, so that is about your incidence matrix. Let's move further, guys. So I will explain one more matrix, then we can end the session. And one important announcement, tomorrow your class will be not live, but it will be premiere for the same time. Okay, not only tomorrow, for the upcoming 4 classes, you will be having the classes. So in Diwali also, Saturday, Sunday also, I have made that class readily available for you, recorded yesterday night and day before yesterday I worked at, okay, I made it available. So Saturday, Sunday, on Diwali also you will be having our digital class as it is. At same time 9:30 to 11:30 you will be having the class. Saturday, Sunday, tomorrow your networks class, the total syllabus will be finished. Day after tomorrow, that is Saturday, Sunday, Monday, 3 classes. Combinational will be finished in the digital. Then sequential first part, sequential second part. Very important, up to JK flip flop I covered. Complete that before coming to the Tuesday class. Tuesday I will be back on live, but classes will be continued up to Monday also. Up to Monday, every day you have class. You continue your learning. It should not stop. Okay, even in the festival also. So please understand that everything I have given, I have made the classes readily available. You will have the best experience as regular classes. And again Tuesday we will meet. But before coming to Tuesday, complete the classes and come, because that requires the knowledge of the previous classes. From next week onwards, daily same time. Okay, I will announce either 9 or 9:30. We will continue the digital crash course completely. Completely, we will complete it by the end of this month. I am planning to complete it also. Okay, so let's move. Okay, right. So the next one we are going to discuss is called Triset matrix, or you can say Triset matrix, or fundamental loop, F loop or F circuit matrix, all are same. It is represented by the letter V, suffix F, that is fundamental circuit matrix, fundamental loop matrix, Triset matrix, all are same. How to make a Triset matrix I will show you now, right? So these are the steps you should follow. Before following this, let me take a graph again. So let me take the graph. So after taking the graph, the first point is the same. What is the first point I have given there? Select a tree. First we will do that. Okay. So step by step we go so that no confusion. I select this tree. You can select any tree of your choice. It is your wish. Whatever you like, you go for it. So this is the selected tree. Okay, I have selected this tree. What is that? A tree of 2, 4, 5. Sir, first point is done, sir. Tell me what to do. Second point. Addition of one link at a time will give one F loop at a time. So for this particular tree of that particular graph, add one link at a time. Add one link at a time. So let me add here one link. This is one link. Next, add another link here. Right? And also add another link here. So every link will give you one loop. You can see. Every addition of the link will give you one loop. So right, it is proved or not? Every link will give one loop. This loop is also called Triset or F loop or F circuit. Last point, take the link direction as your Triset direction. So you should take this direction and write the loop equation. So step by step, if we go, there is no chance of any confusion. Right. So if you take the loop equation, here it will be V1 plus V2 plus V4 equal to 0. What is the loop equation here, sir? V3 plus V2 plus V5 equal to 0. Here V6 opposite direction minus V5 plus V4 equal to 0. Here we took only one link at a time. We took only one link at a time. Okay. Okay. We took only one link at a time. First V1, next V3, next V6. Okay. So please listen here. This one, right? So one loop at a time, we should take one link at a time. Okay. So is this clear? Now we should write this in the form of matrix. Let's do it. Okay. So now let's take a matrix. Okay. So V1, V2, V4, V5, V6. V2, V3, V4, V5, V6. V1, V2, V3, V4 minus V5, V6. So this is what we call incidence. What is that? Triset matrix into V1, V2, V3, V4, V5 and V6 equal to 0, 0, 0. Yes, you tell me here how many rows are there? How many rows are there? 3 rows are there, sir. Why 3, sir? Why 3? Why 3? Number of links are 3. That is, you can say the order of this matrix B is given by B minus n plus 1 into B. Okay. What is the order of this matrix? B minus n plus 1 into B, because number of rows, each row is called one Triset. This totally called as a Triset matrix. If you take each row, it is called as one Triset. How many Trisets are possible is equal to number of links. Why only one link at a time, sir? To avoid redundancy. It will indirectly give you number of independent loop equations required to solve your network, which will cover every branch, but only at least one new branch is compulsory present in every loop. Right? So this is about your Triset matrix. Now listen here. So if you take this Triset matrix, in that 1, 2, 3, 4, 5, 6. In that, let's separate 2, 4 and 5. Okay, why you separate 2, 4, 5, sir? What is the need for separating 2, 4, 5? Just I will tell you, 2, 4, 5 first separate it. 2, 4, 5 columns. That is 1, 1, 0, 1, 0, 1, 0, 1, minus 1. Right? And the remaining you write it separately. What are they? 1, 3, 6. Okay. Otherwise, okay, 1, 3, 6. Then 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So, right. If you see this matrix, okay, if you see this matrix, guys, it is a B matrix in the form of links and twigs. Yes or no? These are called links and these are called twigs. Yes or no? These are twigs, these are links, because these are tree branches, these are co-tree branches. If you observe, B links is always identity matrix 1 0 0 0 1 0 0 0 0. So you can find B twigs. If you know B twigs, you can make the total matrix B. Why B links is always identity? Because you are selecting only one link at a time and we are taking link direction as the reference. So it is always positive and only one at a time. Okay. So right. Is it clear, guys? Shall I move further? Shall we move further, guys? Please comment. Right. So these are the properties of the Triset matrix. Every Triset consists of only one link in its representation. I have given you that. Number of Trisets is equal to number of links equal to B minus n plus 1. It is also equal to rank of Triset matrix. Right. Next. How many Triset matrix possible in a given graph? Here it is not unique. Incidence matrix is unique, but it is not unique because if you take a different tree, different matrix is possible. Number of Triset matrix equal to number of trees. Number of Trisets is equal to number of links. Okay, Trisets means each row is a Triset. Total package is a total matrix is called Triset matrix. Trisets are nothing but the number of mesh equations required to solve the corresponding network. And also another important point is, if you take B transpose into IL is equal to I. This will relate the loop current with the branch current. Okay, so please listen here. 1 minute. Yes, these are the branch currents. These are the loop currents in direction of links. Loop currents in the direction of links. That is about your Triset matrix and its properties, guys. Right. So let's move further. The remaining part we have is a cut set, okay, cut set matrix, etc. Those things we are having, those things we will discuss in the next lecture and finish the problems also. Okay, right. So let's move. Hope I have given you the best possible content for you. Your side, just revise the notes, do all the problems, prepare the PYQs. PYQs also I am solving this month. I will make at least last 10 years available in this. Okay. that is enough for your exam, guys. So these are about your details. So right, that's all about today's class. We will meet again in the next classes, guys. So if you join Unacademy, don't forget to apply the coupon code Shankar10. Whenever you join, you should compulsory remember this code. Right? Chalo. So that's all for today. Bye bye. Love you all.